Dabowski reported average elimination rates back in 1976, and he's probably, this is probably the most cited citation is Kurt Dabowski, and he came up with 0.015 grams per deciliter per hour. The statutory blood alcohol is 0.08 grams per deciliter, or grams per 100 mils. So, and it's slightly better for females for some reason. On average, they metabolize alcohol just slightly quicker than males on average. But they both, you know, there's a range of 11 to 20 or 22 on that. So if you use these published average elimination rates, you can estimate a blood alcohol at a previous point in time. And then everybody has, it seems that everyone has done research in this area. Pretty similar numbers, but they came up with the same ranges within the study. So at most alcohol concentrations, and that is anything over 0.02, ethanol is eliminated at a steady rate. So if you know a blood alcohol concentration, you can estimate to a previous point in time. And the example I'll give is a driver at a 0.07 measured 2 hours after an accident. What was the alcohol at the time of the accident? Okay, I have to make two assumptions in the form of a hypothetical. Number one, that the driver is post-absorptive at the time in question. They're done absorbing the alcohol. They're in that elimination phase. The alcohol is going down. Okay? And generally speaking, that's going to be 45 minutes to 2 hours after the last drink. Although there's lots of studies that show those last two drinks, that's the common defense we hear all the time, is that, well, I drink right before, I was stone sober at the bar. Last 10 minutes I was there, I slammed 8 beers, got in my car, had a crash. 2 minutes later, I was sober, but by the time they drew my blood, I absorbed it, Well, that's not realistic. And I'm also going to make the assumption that the driver is, I'm not even going to say this anymore. I'm not going to say normal state of health. I'm just going to say that they metabolize within the normal range. That seems to be a reasonable assumption. And I will use a range. I will never give a very precise number because it's just silly. You don't know what their actual elimination rate is. But if you put them in a normal range, you should be able to give a range when you testify. Now there's tons of evidence that show that chronic users and alcoholics have actually much higher elimination rates. So any estimate you would make for them, if you actually knew their blood or their elimination rate, would be higher. So this definitely gives the benefit of the doubt to most defendants. So here's an example. Driver drinks at a bar, leaves at 12:30 a.m., 1:15, involved in a crash, 3 o'clock blood draw, blood alcohol is measured at a 0.072. What's the estimated blood alcohol at 1:15? Again, I'm going to use a range. So I'm going to have a low estimate, I'm going to have a high estimate. My low estimate is going to be based on using the bottom end of that, the 0.01, or grams per deciliter. My high estimate is going to use that 20 to come up with the number. So we start with the 0.72, we add the time times the rate, add those two together, and we come up with a low estimate of 0.089, or a high estimate of 0.107, within a reasonable degree of scientific certainty. So I'll just blast through these. You'll see these in other slides. 0.105 subclinical. You may not see any behavioral differences or impairment differences. Before we go on with these slides, any questions about this back extrapolation, this estimating based on a later blood alcohol? Has anyone had to do this in one of their cases? Brendan has, you have. Okay. And all the forensic scientists that I train should be able to offer this testimony for you. There's defense guys out there that do it. They should be using the range. I usually don't have many problems with the guys that are doing, other than they're not qualified. But this is not that difficult, so they can't. It's not like they can't master it.